So hi dear students, welcome to the video lecture series of ME 306 Advanced Manufacturing Technology. So in this lecture video, we'll be dealing in detail your module 5. So the module 5 actually deals with your high velocity forming of metals. The entire module is all about high velocity forming of metals. So this lecture video is actually divided into 3 videos. And the first video will be given an introduction about your high velocity forming, and second video will deal with the different types of high velocity forming processes or methods, and the third video will learn the underlying principles of this high velocity forming and its effects on different metals. Okay, now let us start our journey with your high velocity forming of metals. Now before going to the concept of high velocity forming, so the if we consider it word by word, it's actually high velocity forming of metals, right? So let us keep this high velocity apart and let us first try to learn what is forming of metals, right? So let us move on with forming. So you guys might have already seen what forming actually is. Okay, as a simple example, you might have also done your sheet metal process or sheet metal working in your first year's workshops, wherein a sheet metal was taken, it was bent to a required shape, and it was cut and all, and finally you might have produced a required product with the sheet metal. So all those process comes under forming. So that you are taking a sheet metal, you are transforming that sheet metal to a product by changing the shape and size of the sheet metal. So forming can be defined as a process of obtaining the required shape and size. Okay, it's a process of obtaining the required shape and size on the raw material by subjecting the material to plastic deformation through the application of tensile force, compressive force, bending, or shear, or a combination of all forces. Okay, so simply your forming can be defined. In simple ways, you can define forming as transformation to a new product by plastic deformation. Plastic deformation means once the product is formed, there is no turning back. It cannot come. It becomes a new product. Okay, unlike elastic forming, it won't retrace its shape, lost shape. Okay, and that is by application of any type of force. Okay, irrespective of the type of force, it undergoes plastic deformation and produces a new product. So it is a very important manufacturing operation, and it is very important because it is cost effective, and you'll get enhanced mechanical properties, and the operation is flexible. You get higher productivity and all. So one of the main application of this formed products is in automotive and aerospace industries, and also that is used in defense and other industries as well. So basically the tools are called die and punch for a forming process. Okay, now this forming process can be mainly classified into two different types. One is a bulk deformation or bulk forming, and the second is sheet metal working, which we have already spoken of. So bulk deformation, in bulk deformation, some of the examples of bulk deformation are rolling process, forging, extrusion, and drawing, wire and bar drawing. All these processes you might have studied in your manufacturing technology subject in your previous semester. And the other type is your sheet metal working. Sheet metal working, as you have already done in your first year, these are the basic process: bending operation, deep drawing, shearing process, and all. Now let us see in detail what is this bulk deformation and all. Bulk deformation, it's a severe deformation process resulting in massive shape change. The surface area to volume of the work is relatively small and is mostly done in hot working conditions. Okay, so this actually there are two types of working condition. One is a hot working and other one is a cold working. We'll see it later. Right now, the bulk forming process. These are the different types of bulk forming processes. Okay, starting with your rolling, followed by forging, extrusion, wire drawing. All these are bulk forming processes, and normally these are done in hot working conditions. Now let us see how a rolling process looks like. Okay, so now this is an example of rolling process. You can see So you can see two rollers, and a sheet metal is passed in between the roller. So as the sheet metal is passed into the roller is in a particular shape as per the shape is uh, designed in such a way so as to get the final product. Okay, now the sheet metal is passed in between these rollers, and as the rollers rotate, it transforms the original sheet metal to a new shape and size. Okay, by thereby transforming the entire product. Okay, so a series of rollers are kept because it depends upon the angle. First one will deform it in a small angle, second one will increase the angle, and third one, and it continuously goes because it should not break or it should not tear off. Right. So this is a simple example for a rolling process. Now let us also try to see the extrusion process. So your extrusion process looks something like this. Okay. So in an extrusion process, your whatever metal is to be extruded is kept, and it is subjected to a force, and it is moved in through a die. Okay. When it moves through a die, the shape gets changed because of the force. We'll see this the one that is shown in the figure is actually a tool. It's a replaceable tool. Okay. Now a force is applied on the tool. See, as you can see, a force is applied on the tool, and it pushes the workpiece into the die. Okay. So what happens inside the die is as shown in the figure. Okay, you can see from the animation. So when the force is applied, the metal is forced through the die, and it changes the shape, and you will get a smaller diameter one. Depending upon the die, you will get the final product. So this is a simple example for extrusion process. So in an extrusion process, a force is applied, and it is moved to a die, and you will get a new product. That's it. Now, so these are the example. These are the example for bulk forming process. Now, the second type is, as we have spoken of, it is nothing but your sheet metal process. Okay, so in sheet metal process, you will get different types of process. All these processes you might have done in your lab, in your workshop. Sorry, right. So the forming and cutting operations for found on sheet metals comes under forming process. So in short, your forming process, you can define it as from all these examples you can see that once a new product is formed, that's it, right? So a forming process is actually is a process of changing the shape and size of the object by plastically deforming it. It is deformed plastically by application of any type of force, right? Now, this forming process can be done in two ways. One is by cold working, where it is done, and the complete process is done at room temperature or slightly below the room temperature. So it has different advantages compared to hot forming process, and that is you'll get a perfect good surface finish, and the tolerance will be good, and because of strain hardening, you'll get a higher strength product, and all, and etc. All these things are the basic advantages of cold working process. Now it also has some disadvantages. That is, higher forces and power are required since it is not since it is in the cold working condition. It's in the solid condition. To deform it, you must need a higher force compared to the hot working process. And the strain hardening of work metal limit the amount of forming. So it is not possible to cold form all the metals. Right. Now, coming to the hot working process, in the hot working process, the same process is done. The only thing is that the metal is heated above recrystallization temperature. And the basic advantage is that significant changes in, actually lower force is required as compared to the cold working process. And materials with premature failure can be hot formed. Right? And the absence of strengthening due to work hardening. And the disadvantages are main disadvantages that you'll get a poor surface finish compared to the cold working process. The surface finish will be poor. So finally, you'll have to do some machining process in order to use for other applications. Okay, and the dimensional accuracy will be lower, and it is subjected to surface oxidation. Since it is high, since it is in a heated condition, the tendency to react with oxygen is higher, and hence it produces surface oxidation. And since we are also dealing with a hot material, the tool life is also shorter compared to the cold working process. Okay, so this is a basic basic introduction, because this is a basic concept about the forming process, right? So effectively, it is you are getting a new product, right? Now, in this forming process, from the videos itself, you have seen that the workpiece is a is pushed, or a force is applied on the workpiece, and that is moved through a die to produce a new product, right? And the velocity with which this force is applied is very low. You can see from the diagram itself. It can be seen with our bare eyes how the deformation is happening on the metal, right? So the velocity is very small. Now, so there is actually a practical difficulty to form all the metals. Okay. So basically, uh, when it comes to when it comes to automobile and aerospace industry, the main thing is that the important thing which this automobile and aerospace industry concentrates is a higher efficiency and lower weight, right? So as far as automobile industry is concerned, all we need is a higher efficiency vehicle, with a high power and all, right? So in order to increase the efficiency, you need to reduce the load, right? In order to reduce the load, you have to you the perfect material for an automobile is a material with a higher strength and lower weight. Weight is lower and strength is higher, right? This is the desirable property for an automobile as well as for the aerospace industries. Aerospace industry, since it is to be transported to the outer space, all we need is a lightweight, but the strength should not be compromised. Correct. So one of the best material for this process is actually aluminum and high strength steel. High strength steel alloys, aluminum alloys, and high strength steel alloys. But the problem with these two materials is that it cannot be formed easily, because since it is happening at low velocity, the the tendency to form cracks is more for these materials. Now, how can we solve this problem, right? So as a summary, all we need is a material with a high strength and lower weight, and aluminum alloys and high speed steels, or high strength steels are the best suitable material for this. But it cannot be used to produce a complex shapes, because it produces it tears off while subjected to forming process. And because of this only, stainless steel are used in most of the automobile industries in previously. Okay. Now after this, now since this was a problem, as we all know, necessity is the mother of invention, right? So because of this necessity came this new process, and the process is called a high velocity forming. The only difference is that it is actually the forming process, but it is subjected to a high velocity, or it is also called a high energy forming process. Okay. So the basic concept is that as the velocity increases, as you all know, your kinetic energy is given by the equation half mv square, right? Half into mass into velocity square. Okay. Now as the velocity increases, your total energy with which the force is applied also increases to the power of 2, right? So as the velocity increases, the energy also increases. So the process is also called a high energy forming or high velocity forming process. Okay. The short form uses HERF. Okay, high velocity. Uh, sorry, HE. Uh, okay, it is a high velocity forming or high uh, energy forming process. Okay, right. Now, so what is the difference? Okay, so in high velocity forming, a large amount of energy is applied for a short period of time. Large amount of energy for a short period of time. Okay, the high velocity forming gives a large amount of kinetic energy to the workpiece and form it as the kinetic energy dissipates as plastic deformation. Okay, so only difference is there in the conventional forming, low velocity is given and the product is produced. Here, a large velocity is given, a high velocity is given, thereby imparting a large amount of energy, and this is applied for a short period. Since the velocity is large, it is only applied for a short period of time. Okay, so this type of forming is called high velocity forming or a high energy forming. So the high energy forming is based on the principle that kinetic energy of a moving body is proportional to square of the velocity, as I said, and therefore a significant amount of energy can be supplied by a relatively smaller body moving at high speed. The forming process are affected by the rates of strain. We'll see to that in the lecture video 3 how the strain rate is affecting the forming process. Okay. So in a conventional forming, the inertia is neglected as the velocity is very less. That is less than 5 meter per second. Okay. While in a typical high velocity forming, since the velocity is 100 meter per second or more, the inertia effect should also be considered. We'll see to that later. Okay. So in short, all you have to understand is that high velocity forming, a large amount of energy is applied for a short period of time. Okay. So the basic features of HERF process is that the energy of deformation is delivered at a much higher rate. That is, a large energy is applied for a very short interval of time. Right. So because of this, many metals tends to deform more readily under extra fast application of force. Okay, so many metals, many metals like this aluminum alloys and high strength steels can be formed using this process. Right. So large parts can be easily formed. Even large parts can be formed, and even complex shapes can also be formed using this method. Okay. The strain rate dependence on the strength increases with increasing temperature. The yield stress and the flow stress at lower plastic strains are more dependent on the strain rate than the tensile strength. Okay, all these things we'll see later. Right. Okay, so the basic advantage of this HERF process is that, as we said, it is all required to enhance the mechanical properties. All we see, this method was developed to enhance the mechanical properties, mechanical property of the materials. Right. So the mechanical property of the product is better. Right. So on implementing this HERF process, you will get better mechanical properties, or better product can be made using better metals, right, or metal alloys. Okay, now as I said, uh, since it's a high velocity forming, your product is produced at high velocity. The number of products produced at a particular time will be higher, right? Therefore, the production rates are higher. It's an important advantage, right? The production rates are higher as the parts are made at a rapid rate. Okay, and the tolerances can be maintained. The product shape accuracy is enhanced. Okay, and another important advantage is that versatility of the process. That is, most number of uh, different forms. Okay, and sorry, and different. It is possible to form most metals. Most of the metals can be formed using high velocity forming. Okay, and there is no or minimum spring back effect. Right. So spring back effect is actually, see, for example, if you deform an object, for example, if you just bend a steel rule, okay, it will retrace its path, right? It is actually called the spring back effect. Once you bend it, now if it is retracing its path slowly, or it is from the desired shape, if it is transforming to an, or it is changing that shape after the product is made, that is called the spring back effect. Okay, now if the object is made, or if the product is made using high velocity forming, there is no spring back effect, or it is not seen, right? And the production cost is very low, as power hammer is eliminated in this process, right? Okay, and the complex shapes and profiles can be formed using this process. These are the basic advantages, and the limitation is that it requires a skilled personnel to design and execute. Okay, and it is not suitable for highly brittle materials, and the source of energy. So all these things, you'll get an idea of all these things once you learn the different processes. Okay, the source of energy, normally explosive type high velocity forming is used, and the source of energy must be handled carefully because it is explosive, right? And the government regulations and safety norms should be followed, and dies need to be much bigger to withstand high energy rates and shocks. Controlling the application of energy is critical, as it may crack, right? It is essential to know the behavior performance of the work metal initially. Right. Now, this high velocity forming process is basically classified into there are basically three types of high velocity forming processes or methods. Okay, the first one is called explosive forming. We'll see to that later. Okay, it is called explosive forming. The second one is electro-hydraulic forming, and the third one is electromagnetic forming. Now, the explosive forming is mainly used in sheet metals and sheet metal operations. Okay, and in detail, So as per the syllabus, all we have to learn is the explosive forming and electrohydraulic forming. Okay, we will deal with these two types in the lecture video too. So thank you. So stay updated in the second lecture video. The different types of velocity forming, explosive forming, and electrohydraulic forming will be dealt in detail in the next lecture video. So thank you, Anand.